Hello there and welcome to this tutorial where I will attempt to show how did I create my little HandIK which I have created, which you see on the screen right now. I had to cut this tutorial to two parts because it would have been too long and it would have been too hard for me to edit, so sorry about that. But without further ado, let's start doing it. First things first, we are going to go into our base character blueprint. As you can see, it's unedited yet, so it's a fresh project. I will just go into the TIG graph, and this is where we are going to create a function, which we are going to call HandIK. In my original, I didn't really use functions, so I'm sort of winging it here, but it turned out okay, so first, we are going to need a few function outputs. We are going to check if our hands hit the wall, left and right. We are going to check their positions, which is going to be a vector output, right and left location, and same for rotation. Now we are just going to save it. And we are going to add it to the TIG graph and just click on the add pin and connect it. Go back into the HandIK function and create a function which is going to be for the standing HandIK. That's how I cut it to two parts, basically the standing and the crouching, and we are going to start with the standing because that's where we do the foundation of everything, and that's the easier one. So line trace by channel, and what we need is to define the start and the end position of that line trace. That was my phone. So first, socket location based on our mesh, which we just dragged in from the base character. And by the socket location, we already have our start for the standing IK. And to the end, we are gonna add a few vectors together, 3 to be precise. The first one is gonna be, of course, the socket location because that's our starting point. And from there, we are gonna get vector right vector. And we are gonna multiply it. And the multiplication is basically the distance, how far to the right. So we are just gonna multiply it by a float value. This is gonna be 40, that I found that works for me quite well. And connect it. And for the last one is the forward vector, which is gonna be 40 as well. That's the multiplication indicates how far forward will this go, and just connect it to the end. For the socket name, I'm gonna use the upper arm, and to get the exact name of it, you can just go into the skeleton and copy the bone name for the right upper arm. And just paste it there. Now to the HandIK, we are gonna drag in our newly created function. And as you can see, it doesn't have any outputs yet. So it's not gonna do anything, but we will see the line trace, which we just created. Now let's collapse this whole thing into a function, just to make it a bit cleaner. And let's rename the values, or not, but we will rename them later to start and end. We can do it now. Now we go into our function, rename the function. This is gonna be get standing line trace parameters. Nice and long name for it. And we are gonna get an input which is gonna be type name, and this is gonna be the socket name. And we can connect it, but that's not the way I actually like it, because once you compile, you can actually get the parameter by typing it in, and it's gonna be the same. So I type in socket name, and there you can see it's socket name. It's exactly the same, and it's a bit cleaner if you do it that way. Now, based off of the socket name, what I want to see if it equals to the upper arm right. And based off of that, we're going to create a branch. And just connect this up. So if it is upper arm right, we are going to do this line trace parameters which we created. And if it's false, we are just going to duplicate the output node, connect it to the false, and we only have to change one parameter, which is the right vector, to a negative, because it's going to be the exact opposite. We can make this function into a pure function, so we won't have to connect it. So it will only need the socket name, and it will return our start and end for the line trace. Duplicate the line trace parameters. And now we have reached the point where I actually rename the outputs. And I can just type in the socket name, which is upper arm left. I'm not sure if it's case sensitive, because I know for a fact that it works if you don't copy it and just type it all in lowercase. And now if we save and check, we have 2 line traces from the shoulders. But it doesn't do anything yet. We have yet to do that part. To actually make the line traces disappear at the draw debug type, you just have to set it to none. Okay, we split the struct pin of the out hit. You can also use a node to break the out hit result. I think it's called break out hit result. Anyway, from the return value, we are just gonna create a branch. And if we don't have a return value, that's where we are gonna jump to the next line trace. This is just my setup, because I set it up so that only one line trace will work at a time. I mean, one IK. Now here, from the out hit location, I'm just gonna promote it to a variable, and that's gonna be our right hand location. And I will call it right hand last location, because we are gonna save the last location which was recorded if there was result. That prevents us from glitching. And for the out hit normal, we are gonna convert the vector to a rotator and then split the struct pin there. But I'm just gonna promote it to a variable this time. We are gonna set this later. And we are gonna save this as a variable too, of course, to prevent the glitching stuff. And let's create our function outputs. Left hand, right hand, it's the same as the HandIK output. We are gonna connect them later on. So left, right location, left, right rotation, and of course the booleans if any of the hands hit the wall. And we are gonna just connect it. I'm gonna drag in the right hand location and rotations, You can obviously connect the ones from the set, so you don't have to drag them in as a get, but it's a bit cleaner. And don't forget to tick in the right hand boolean, or you can actually connect the return value to the right hand and add it, but this is the way I prefer it. Okay, we have created the same variables for the left hand as we did for the right hand and just drag them in. And the way we are going to distinguish which hand to rotate and locate are going to be based on the booleans. I'm just going to copy this whole thing for the left. Set the condition to the return value, replace the right hand and the left hand, and connect the out hit normal. It's basically exactly the same as the above, but don't forget to actually check the left hand instead of the right hand. Right there. And there will be other differences too, so it's not done, but for now this is how we are gonna roll with it. And for the final false, it's gonna be returning the same thing, but none of the boxes ticked. Compile and save. And let's go to the NMVP. Now we will have to convey all of our variables and informations into this graph. So since it's not the same graph, we do not have the variables which we set here. So we will have to find a way for that, which is going to be in the update graph and the update character info. So this is where we are going to import it. Conveniently, ALS has an interface for that, which is under character information and the set essential values. This is the place where you set these values. And to reach it, go into the blueprints folder, interfaces, and ALS character BPI. And this is where we can add values to the interface. Just click on the return node and plus it. And just add the same variables which you added there. I'm just gonna drag it into the middle so you can see what I'm typing. But it's basically the booleans, right hand, left hand location, and the left hand, right hand rotation. Boolean, boolean, vector, vector, rotator, rotator. And always save before you compile, because it has a tendency to crash when you compile it, so don't forget to save. For me it did crash, I can't click anywhere, so back here. And now the values which we set in the character blueprint, so these values which we set there, and we are actually setting them, we will set them at the tick graph. So just connect them up. Compile, save. And in the tick graph, I'm just gonna promote everything to a variable. Right click, promote to variable, and just chain them up. And now we have our variables. And in our get essential values, we are just gonna drag in all the variables which we created and connect them to the right place. Be careful not to drag in the last location and last rotation values, because we are using them locally in the function. We do not want them to be mixed up. And I'm just gonna categorize them real quick and drag them in so that we don't have a lot of variables in the air, so it has a category, which is HandIK in this case. And now that we have done this, and we have everything here, we can compile. And if we go back to our animation blueprint, which is character asset, mannequin skeleton, ALS and MVP, and go to the update graph and update character info, you see that we have new values we can work with. They do glitch a bit together, but I'm just gonna move them down so we have the space to work with. And now we can do the all too familiar promote to variable and then chain them up. And connect them up. And now we have all the variables we need in the anim graph or animation blueprint. And now that we have that, we can come in here and start working on the actual IK. This setup is actually going to be pretty simple. I'm just going to cache the two-bone IK for the HandIK actually, and rename it something nice, spine and IK or spine and IK. And let's start working on our own HandIK. First we need a two-bone IK, then a transform modify bone, and don't forget to set the bone to the hand which you are gonna move. In this case it's gonna be the right hand. We are gonna do the same for the left hand, of course. Now the effector is world space, not component space, not bone space, it's world space. Don't forget to set that. And now the transform modify bone, we are gonna set the hand to the right as well on this one, up top. Right hand transform mode, rotation mode is gonna be replace existing, rotation space is gonna be world space. Now that we have that, we can drag in our variables which we created, which is the IK right location for the right hand, and just connect it to the effector location. And for the rotation, we are gonna use the transform modify bone and connect the IK right rotation to that. Now the component pose is gonna be our cached pose. So just start typing in spine and IK or whatever you named the cache, whatever you named it. It's gonna add a local to component node, don't worry about that. You don't actually have to worry about any other values right now. So now what we want to do is actually create a blend poses by boolean, and this is where the right hand hit wall will come in, because if it's true I want to modify the hand right bone, but if it's false I just want to use the cached position. So I'm just going to duplicate that and drag it into false pose. And for now we are going to connect it to the in pose. And now we should have something. Try to get used to commenting your work because it can get complicated really quickly. Okay, left hand doesn't do anything, right hand does. But actually it's not right, because now we are gonna actually work on the standing hand IK's rotation values. So standing hand IK function, and this is the point where we are gonna do something with the rotation. Disconnect the one where we set it, split the struct bin, And I'm just gonna create a make rotator node so that we can create our own custom rotator. Now for the standing IK, it is very simple. For the crouching one, it's gonna get a bit complicated, but that's gonna be in the next part. So for the roll, we are just gonna add to it, so add 90. These can be hard-coded values. There's nothing dynamic you need about it, it's just that the world rotation will place your hand in a weird angle, so you just add additional values. The yaw is gonna be the same, you don't have to worry about that. But the pitch has to be a negative 90. In this case, it's gonna be, I think, different in the left hand. I'm just gonna copy the same thing. And yeah, change the pitch to plus 90 instead of negative. Now compile and save. And now the right hand's rotation is right. And it's gonna already follow any sort of angle on the wall. So your hand's position is gonna be always, so the palm is gonna be always on the wall, no matter the angle you're standing from the wall. Okay, let's actually create the same thing for the left hand. It's gonna be fairly simple. The effector location is gonna be the IK left, the rotator is the left rotation, Boolean is of course the left hand hit wall. Don't forget to change the bones to modify the left. And now the problem is how we are gonna connect this, because there is only one input for the impose. So we have to actually decide which hands to, or when to modify which bone. And it can be achieved by layered blend per bone. And it's gonna blend the two together. But what you have to do is at the layer setup, you have to add the branch filter, and you have to set a bone which to separate it. And in this case, it's gonna be upper arm left. It can be upper arm right, but make sure if it's the right that the right is at the blend pose 0. And now the left and the right both wall. Now there is one more trick which you can do, is subtract 10 from each pitch, so the Y values, so negative 180, and it's gonna pull your hand a little away from the wall so that you can actually see your hands a bit more. But the fingers are still curled, so we have to do something about that. And what you can do is, I'm gonna go into the animation base poses. I'm gonna duplicate the neutral pose. And I'm gonna rename it to new open-handed neutral pose. This is a 1-frame animation. So what I will do, after duplication, I'm just gonna pause it, go to frame 0. And using the skeleton tree, I am gonna straighten up the fingers, and you will see that it's gonna be pretty ugly, but this is for the tutorial purposes, so make sure you actually make a nice hand for yours. And actually, of course, you can use custom animations, so it doesn't have to be a 1-frame animation. If you want your hand to be doing something on the wall, you just create an animation for the hands, and layer blend will actually take care of, so you only have to animate the hands, you don't have to worry about anything else. Just do something with the hands that you want your character to do on the wall. Don't forget to key the 0 frame and the 1 frame, apply it and save it. And how the animation editor works in Unreal Engine is a bit weird, so you have to close it and reopen it to see if it's good. For me it's good, but it can be twitchy. And now to actually incorporate the open-handed neutral pose, what we need is another layered blend for bone. And one of the poses is gonna be the new animation which we created, and the other one is gonna be the component pose. So the cached pose, and then in the asset browser on the side, I'm just gonna search for open-handed, drag it in, and connect it to blend pose 0. And what this will do is, in the layered blend, we will set the branch filter to our right hand, or left hand, because in this case it's the left hand, so that from the wrist down you're gonna see the animation from the blend pose 0, everything else is gonna be the cached one. And then we are just gonna do the same for the right hand. Just gonna make a little space for it. And the only thing I will have to change is the branch filter to right hand from left hand. And now, if we check if it works, it should open the hand when you touch the wall, and it does. And it looks a bit funny and weird because my opened hand is ugly, but yours will look nicer if you put the time in it. For me, I just did it in like 2 minutes, which is not ideal if you want to make something look good. But basically that's it for the HandIK, I think. I mean the standing IK. And one thing you can do is the blend time. You can play with the blend time so it doesn't look like that fast of a transition. So you can make it a bit more natural if you slow it down, how it transitions from the IK to the neutral pose. And you will see how it works now. Takes away from the hand a bit slower from the wall, and I think it looks a bit more natural in that case. So this was the first part. The second part, I think I'm gonna upload it on the same day, but I still have to edit that, and I have to edit this too. So stay tuned, it's coming soon. And it's gonna be a little bit more difficult, but I will try to explain everything the best I can. So see you then. Thank you for watching.